So we're now going to look at indices that have a fractional power to them. The laws are all exactly the same. If you add two, the laws are all exactly the same. So if I look through the laws here, law number one, what we need to understand for this one is how a fractional power translates into an actual operation within. What I need to understand here is what is a fractional power? You may have come across a very regular used. The best example of a fractional power is the square root. Now, we've all come across square root. Essentially, we are looking for two numbers that multiply to give me the number that's inside, which is 2. But the way that we can write square root using powers or indices is that this is actually to the power of a half. We're taking the square root and therefore I've got a 2 at the bottom, which gives me the same answer. So the value of the root, so if I have the cubed root of 8, which in this case equals 2, the way that I can write this one is that it's 1 on 3. So the value of the root is the value at the bottom of the fraction. So that is the relationship between our rational indices and our roots. We are used to already, we already have our powers at the top. So we are used to having something squared or cubed. So that's what our m is. That's just the power that we're raising it to. And that n at the bottom is the root of it. So this could be rewritten as a to the power of 1 on n, all to the power of n. And that's the same as also saying a to the power of m and then to the power of 1 on n. What that looks like in terms of a square root. So for this one here, I will have the nth root of a, whatever that might be, all to the power of m. Or I can write it as a to the power of m, and then we take the nth root of it. So that's what that looks like in root sign. The good thing about this is that all of the laws stay the same. When I add two indices of the same base, you add the powers. When you divide, you subtract the powers. And when you raise a power, you multiply them. Let's practice a couple of these now. So with example 8, evaluate each of the following. For part A, this is indicating to me that I need to take the cubed root of that value. I can take the cubed root of a number because I can take a negative number, raise it to the power of an odd number, and it will come out negative. So a number that goes into 64 multiplies it by itself 3 times is 4, because 4 times 4 times 4 is 64, and because it has a negative there and it's an odd power, I will leave the negative in the answer. So it's negative 4 to the power of 3 will give me negative 64. This has two elements to it. It's got a fractional power, which means it's a square root because it's a 2, and it also has a negative, which means it wants to take it to the other side. So I can rewrite this as 1 over the square root of 9, and the square root of 9 is 3. For part C, there are two parts to this. It's being raised to the power of 5 and to the power of a half. So what I would suggest is always split it up so it looks nice to be able to work with. I will always write the root on the inside because it allows me to make the number smaller before I have to make it much larger. What I mean by is I can take the square root of 16 a lot easier than having to raise 16 to the power of 5. Now the square root of 16 is 4, and 4 to the power of 5 is in fact a large number. Which is 1024. For part T, again, there are 3 parts this time. There's the negative, there's the raising of the power of 2, and there's the cubed root. So I'm going to take the 64 to the bottom. The cubed root means I can write it in this format, and that is all going to be squared. So the cubed root of 64 we know is 4, and that will leave over 4 squared. So that's 1 on 16. Example 9 is all the same, it's just a little bit more complicated looking. Here we have 3 to the power of a quarter. before I go ahead and try starting to simplify here, what I can notice is that I've got a few bases that can be rewritten in a simpler form that allows me to add or to subtract some of the powers. So at this point, I can't add or subtract anything because I have no similar bases. So what I can think about is that, first of all, I can write the square root of 6 as to the power of half, and I can write the fourth root of 2 as a quarter. And that's all on 16 to the power of 3/4. Now, I can rewrite 6 here as 3 times 2. And the reason that that's helpful, is I can now rewrite this as 3 to the power of a half times 2 to the power of a half. So all I've done is I've split it up. Just in case you're not sure how each of them got the power, so I can rewrite 6 as 3 times 2, and then remembering that each term is to the power of a half. Now the 2, I can't really split that up, can't do anything with it, but I can split the 16 up. I can rewrite 16 as 2 to the power of 4, and it's already to the power of 3/4, so what you will notice is that that's 4 times 3/4, which is quite convenient. If I just do it up here, 4 times 3/4, the 4's cancels out. So it's actually going to end up being 2 to the power of 3. So what this whole process has allowed me to do is just simplify my value so that I can add everything together. So now the bases 3's, which are over here, I can add the powers together. So a quarter plus a half is 3/4. For the bases of 2, that's again a half plus a quarter, which is 3/4. I can add the bases together, which again is 3/4, and then that's all divided by 2 to the power of 3. Now, there's not much I can do with 3 to the power of 3/4, so that's going to stay as it is. But what I do know is that I can subtract values when they're being divided. So that's going to be 3/4 minus 3. I want it to be on the same denominator, so at the moment it's on the denominator of 1. I'm going to multiply both the top and the bottom by 4. So that will be 3 minus 12, which is going to be negative 8 on 4, which is negative 2. That's not right. That's negative 9 on 4. Which is negative, oh, negative 9 on 4. So what I now am going to have, so I've got 3 to the power of 3/4. This will cancel out, and that will give me a negative 9 on 4. Ooh. So what that means is that when I divide 2 to the power of 3/4 by 2 to the power of 3, that's going to leave me over with 2 to the power of 9/4, and because it's a negative, I'm going to take it to the bottom. And there we have this quite complicated equation completed. For part B, very similar idea. I'm just going to expand the powers in and then cancel out anything I can. So here I've got x to the power of a half times, x to the power of 2 times a half. So 2 times a half is just 1, so that'll be x to the power of negative 1, y to the power of a half times x to the power of 4 on x to the power of, on y to the power of negative 12. Anything that's got a negative, I'm just going to underline that, take it to the other side. So that will be y to the power of a half on x times x to the power of 4, y to the power of 12. That's just on 1. 1x here, 4x is here, that will go, leave over 3, and then I can add the powers of y. So that's 12 plus a half, which is going to be 12 and a half, or 25 on 2. So that will leave over x to the power of 3 and y 25 on